welcome to our hackathon submission, Building Better LLM Applications for Underrepresented Health Conditions with TruLens. So here's our team, and here's the problems that we are trying to address. The solution that we are using TruLens on is our TMJ and Orofacial AI Physical Therapist tool. And we are comparing ChatGPT Vision with our custom model that we made in Vertex AI. And here is the prompt that we used for GPT-4 Vision, where the user would take a photo, send it to GPT-4 Vision, as well as the exercise that they were doing, and then we would send an associated prompt. So in this situation, we're doing the goldfish exercise, and this is the prompt. And this is the response that we got from GPT-4 Vision. Now, when we did it with our custom model, it's a little different because we passed the photo to first our classification model that we built in Vertex AI. Then we pass the percent probability of the prediction to text Bison and with a prompt like so. And we get a response like this. So the way that we built this classification model is we utilized this YouTube video and we took screenshots and built our custom data set, and we fed that into a classification model in Vertex AI. And here were our metrics and precision recall. And here is just our classification model in action. So the user takes a photo, and then it gets sent to the classification model, and above you can see it predicted the exercise resisted close, which is correct. So that's just how it's working. So we wanted to compare both of these with TruLens, and so we did the following code. And with that, we saw not a huge difference between the two. We were surprised to see that our custom model actually performed slightly better. However, due to the simplicity of simply just calling GPT-4 Vision, we decided to proceed with GPT-4 Vision and incorporate some RAG using a Zillis database so that the user could get the best possible outputs from an AI physical therapist that they could. So we had this kind of layout where a user would send the image to GPT-4 Vision. That result from GPT-4 Vision would, instead of getting sent to the user, we would improve it by sending it to our Zillis database and performing a vector search where we would retrieve documents. And then we would take that original GPT-4 Vision output as well as our documents, and we would kind of enhance that result and then pass that output to the user. So we used these articles, we used Gecko embeddings, and we put them into our Zillis database. And here is just a demo of the website at play. So the user would simply turn on their camera, they would select the exercise where they could see the steps, they would take their photo, and then that photo would actually get sent to GPT-4 Vision. As we can see here, we get the Vision response. It turns that into Gecko embeddings, it gets the relevant documents, and then it improves it with text Bison. So here we can see the better result. So you can compare the GPT-4 Vision alone, the response alone, versus its RAG boosted results. And then here is just, there's also, the user can simply text the chatbot if they wish, and then they would get a response from Vectara with the same exact articles, and it's just giving the text communication in this way. And so here's just a response that we wanted to test in TruLens, and these were the documents that were retrieved. And this was the query that we compared it against in TruLens. And these were our results. So we saw that our groundedness and our context relevance were not as high as we would like. However, our answer relevance was really good. Luckily, with TruLens, we got to see the reasoning function, so this was very helpful because it actually gave us a peek into what was going on. And we actually found out that our supporting evidence for the LLM was very strong for 3 out of 4 of its statements. The only statement that was scoring low was actually the classification of the image. And that's because we didn't pass the image embeddings to TruLens, so it couldn't evaluate. So it was giving a score of 0, but in reality it should be a high score of 10. So we were able to understand that actually our groundedness is very good. And then we did the same thing with context relevance. And we just learned a lot using TruLens. We want to use maybe improve the documents that we're retrieving, perhaps by doing a hybrid search. We want to experiment with multimodal databases so we can actually have images and text searching, and this would improve our context relevance, and additional things to improve with our summarizing, like using Vectara, combining these results with Chat Bison. And so thank you so much, and we hope you enjoyed our submission.